Seeing is understanding the power of data visualization. Data is everywhere. We use it to make decisions, understand trends, and even predict the future. But raw data can be overwhelming. It's hard to make sense of rows and columns of numbers. That's where data visualization comes in. Data visualization turns numbers into pictures. It helps us see patterns, relationships, and stories that are hidden in the data. Imagine trying to understand the spread of a disease just by looking at a table of numbers. It would be nearly impossible. But with a map showing the number of cases in different areas, we can quickly grasp the situation. One famous example is John Snow's cholera map from 1854. By plotting cholera deaths on a map of London, he identified a contaminated water pump as the source of the outbreak. This visualization saved lives and revolutionized public health practices. Data visualization is not just for scientists and researchers, it's a powerful tool for anyone who wants to understand the world around them. Whether you're a business owner tracking sales, a teacher explaining a concept, or a citizen exploring government data, visualization can help you make sense of information and communicate it effectively. Beyond charts and graphs, introducing the grammar of graphics. When we think of data visualization, we often think of charts and graphs. But there's a deeper level to creating truly effective visualizations: the grammar of graphics. Just like grammar provides rules for constructing meaningful sentences, the grammar of graphics provides a framework for building meaningful visualizations. It breaks down the process into distinct components, allowing us to create a wide range of visualizations from simple scatter plots to complex interactive maps. The grammar of graphics was first introduced by Leland Wilkinson in his book, The Grammar of Graphics. It's a powerful concept that has gained widespread adoption in the data visualization community. Instead of relying on predefined chart types, the grammar of graphics encourages us to think about the underlying structure of our data and how we want to represent it visually. This allows for greater flexibility and creativity in our visualizations. Deconstructing visualizations, the 7 building blocks. The grammar of graphics consists of 7 interconnected components that work together to create a visualization data, the foundation of any visualization, representing the information we want to communicate. Aesthetics. How we visually represent data attributes, such as position, color, shape, and size. Geometries. The geometric shapes used to represent data points, such as points, lines, bars, and areas. Facets. Dividing the data into smaller subsets to reveal patterns within groups. Statistics. Statistical transformations applied to the data, such as calculating means, counts, or trends. Coordinates. The system used to map data onto the visual space, such as Cartesian or polar coordinates. Themes. Visual elements that control the overall look and feel of the visualization, such as fonts, colors, and backgrounds. By understanding these components and how they interact, we can create visualizations that are not only visually appealing but also informative and insightful. Section 4. Data. The foundation of every visual story. Data is the heart of any visualization. It's the raw material that we're trying to understand and communicate. Data can come from many sources: spreadsheets, databases, APIs, or even text files. The important thing is that it's structured in a way that allows us to analyze and visualize it. Before we can even think about creating a visualization, we need to understand our data. What variables do we have? What are their data types? Are there any missing values? What are the relationships between variables? Once we have a good understanding of our data, we can start thinking about how to visualize it effectively. Section 5. Aesthetics mapping data to visual elements. Aesthetics are how we visually represent data attributes. They are the visual properties that we can perceive, such as position, where a data point is located on the X and Y axes, color, the hue, saturation, and lightness of a data point, shape, the geometric form of a data point like a circle, square, or triangle, and size, the area or length of a data point. By mapping data attributes to different aesthetics, we can create visualizations that reveal patterns and relationships in the data. For example, we could use color to represent the category of a data point, size to represent its value, and position to show its relationship to other data points. Section 6. Geometries, choosing the right visual representation. Geometries are the geometric shapes used to represent data points in our visualization. Choosing the right geometry depends on the type of data we have and the message we want to convey. Some common geometries include points, used to represent individual data points, often in scatter plots, lines used to show trends and relationships over time or across categories, bars used to compare values across different categories, and areas used to show the magnitude of values over time or across categories. Each geometry has its own strengths and weaknesses, so it's important to choose the one that best suits our data and our message.